All right, folks, welcome back to Mike and Maurice's Mind Escape. We have episode number 137 today. We're going to be talking about recent science news and discoveries. I retweet a lot of stuff on Twitter, different articles and updates and different science alerts and things of that nature, and people send me emails saying they appreciate them and stuff like that. So I figured let's just do an episode where we talk about some of them and go through the list. And I just went through my history and pulled a bunch of cool ones out, and we're going to be doing that.
It's good to stay in touch with the current event type things.
And don't forget to subscribe to our channel, hit the like button. If you are listening on an audio platform, please subscribe, leave us a nice review, and check out our website, mindescapepodcast.com. And also you can support our show by going to Patreon at patreon.com/Mind Escape Podcast. We have exclusive episodes on there for just $2 a month. And Maurice and I are also working on possibly making some t-shirts and some merch, and maybe even selling some of Maurice's artwork on our website as well.
Yeah, if anybody has any suggestions for shirts, leave a comment below and we might take it into consideration.
And we might not. But here we go. Let's get into it now. So the first one I want to get to here is one that I posted the other day. Some of these are a little bit older. They're probably all within the last, 3 or 4 months, I'd say.
Mm-hmm.
And we have a bunch more too, so maybe we'll do this every other week or something. But
this will never end.
So the brain builds structures in 11 dimensions. A Swiss research team called the Blue Brain Project has been trying to build a computer model of the human brain. They've been using algebraic topology to discover that our brains build these structures in 11 dimensions. So, this, some would say that your mind goes to the thought that maybe there's more than meets the eye now. And this is based off of like the three spatial dimensions that we have, and then time being the fourth dimension, and then like 7 mathematical non-spatial dimensions. So it's kind of, I don't know, it's interesting, but at the same time it's like it's not the woo we want, right?
Yeah.
I mean, we want there to be more spatial dimensions, and not that I think that science is pretty sure that doesn't exist. But as you'll see by going through these different articles, there's a few things that just don't line up either when you're talking about like the model of the universe and how we don't know some things. And it seems like they try and use math to kind of fill in the gaps. So my question would be to somebody that really knows what they're doing, whether it be a mathematician or a physicist or somebody that uses mathematics to prove a lot of their stuff, how accurate is it, and could it be wrong? Because it seems like you could try and fit some things into different holes or parts that maybe don't fit, but you make it work, that kind of a thing.
Yeah.
So that's what I would like to know if I was going to ask somebody.
Well, we already know that in 100 years from now we're going to look back and laugh at our stuff. So
right,
we talk about that all the time. But yeah, no, I mean that's all they can really do right now is to try and fill in the gaps to the best of their abilities. But you talk about, well, we'll get there in a minute here.
They found that neurons connect or group up and they create these little cliques. Some went up to 7 dimensions, and they even found some that went to 11 dimensions. So it's like the way that these neurons like bunch up in a certain type of way, then that they interact with each other.
Right.
And the extra dimensions are not, again, they're not spatial dimensions. They are abstract mathematical spaces. So
what does
at
what
the
does
bottom
that
right
mean?
there, if you're looking at this slideshow, there is a algebraic topology or a little figure there. It's called a torus, Torus, and it looks like, if you ever see the model of the universe is like a donut, when they show that's exactly kind of what a torus is. So, and we have roughly up to 86 billion neurons. I think that's the recent count.
Wow.
That's a lot.
Yeah.
That's a lot. But it's interesting when you think about the brain and how we keep, going back and forth on these different things and consciousness. And obviously, scientists are trying to prove consciousness via material or your brain matter or interactions within your body. But we do also know, like I just read an article the other day, that you can't trust the fMRI scans from like the last however many years, because there's been studies that tried to like correlate different parts of the brain to different functions, and they realized through this study that people use different parts of their brains for these different functions, so it's not consistent throughout people in general. So you can't really apply that if it doesn't apply to everybody. So
Yeah, that's the thing. Every hypothesis they have with the brain doesn't always apply, so then they have to go back to the drawing board.
what do you think about this though? I mean, that's like
You know what I think, bro? I think we're receiving a transmission that doesn't end when the brain shuts off. And I mean,
Yeah.
we can look to some of these out of body experiences or near death experiences where the brain has actually been pronounced dead, but these people are still living to some degree.
Mm-hmm.
So what's going on there? Again, they try and
There was that article
disprove
out
it.
there too that like you may be aware that you're dead for like up to a certain amount of time after you've died somehow. I don't know what they attribute that to. Maybe not all.
Yeah, but what if time only applies to an actual living being, and when you pass away, yeah, you might be only alive for a minute, but that minute might be eternity because you have no actual physical body anymore that's using time to decay.
I mean, again, but that's still predicated on when all systems shut off. Does it go somewhere? Like, does your consciousness go somewhere, or does it just die with the body, or are you conscious
Yeah.
for a little bit after, like you're saying, and maybe you're stuck in that loop or whatever? So I don't
Well,
know.
I think science has a bad way of looking at everybody as an individual, or like I respect people as individuals, but I'm talking about when you actually die, you might be absorbed back into the main oneness with the universe, if you will. So again, all this materialistic stuff always kind of filters down into this whole agenda, if you will, of what they want people to believe, that they're all individuals, and then like all things are like the world you see around you is the only world that exists.
Yeah. And I mean, and the way I think about these things, if you've been paying attention recently, is I don't know what to think. I want to believe, obviously. Who doesn't? Who doesn't want this to continue? And I think if you ask most people what their greatest fear is, it's death, because death is
Right.
the great unknown. Nobody knows what happens when you die.
Oh,
People
for sure.
have died, obviously, and had near death experiences. Those people have something to say about it. But other than that, there's no way to actually prove one way or the other. So
That's why that idea stuck so hard. Me and Michael have been talking about doing a documentary on near-death experiences, and I think it's a really good idea because I think it would inject some hope into people. Again, we've talked about this. When you believe that your life ends at death and there's nothing more and there's no purpose, that has an effect on the way you live your life. I'm not saying everybody's going to go out and start robbing stores and committing massive crimes, but again, that kind of thought pattern seems to lead more towards a depressed type of person.
yeah, so actually, in Socrates had something to say about that too, in the sense that when you don't have anything to believe in, so like when the sophists came along, even though Socrates was lumped in with the sophists, we've talked about that on our ancient Greece philosophy episodes. He actually wasn't. He didn't receive pay, and he wasn't doing it just to help people win arguments using rhetoric, etc. But he did want to teach people, and he taught people by asking them questions that would force them, the Socratic method, force them to learn more. But his point on when you don't have faith, faith is bad. When you don't believe in anything anymore, or you have purpose, teleology, then things become very morally and ethically unstable.
Yeah.
And I think you see that a little bit in the world right now. Everybody, there's chaos everywhere because there's a lot of reasons, obviously.
Yeah, a lot of stuff's hitting the fan.
But in terms of you look at religion is no longer a thing. So what's the transition for human beings now that people are rejecting religions across the board pretty much? I mean, there's still a lot of religious people out there, but I would say the mainstream is not very, religious at all. So, and I think you see a spiritual movement happening too, and that's cool. I would consider myself personally spiritual. But yeah, I don't identify with like a religion, but just having that one thing to believe in, some higher power, kind of keeps you accountable.
Yeah. Well, it definitely makes your life worth living to a degree. Again, you have your Neil deGrasse Tysons who are very hard on the materialistic world, and they still seem to find a reason to be around. But yeah, it's an interesting and slippery slope.
Yeah, I would agree. Actually, some of the older Neil deGrasse, he's just very excited. He's got a good vibe to him. But his most recent Joe Rogan one he did, he talked. He was talking over Joe Rogan the whole time, and it was like it was almost unbearable to listen to because Joe would try to ask a question, he'd talk over him. And he just wanted
I remember that.
He just wanted to hear his own voice. I think it was like right after he came back from all those allegations that were against him with all that stuff. So. Who knows if he was trying to prove a point or he was just not used to media appearances. I mean, I don't know what was going on there, but yeah. So I think that's an interesting one. But again, it's not really that.
It's kind of just an update of where they're going with it.
Right.
No, it's no breakthrough here, but we'll keep in touch with that and we'll see what happens over the next couple of years. Again, I think. The time we're living in, I think it's an exciting time, especially for some of the stuff that we're doing. But in my vision, I feel like we were doing this for a reason, that we were drawn to do this. I think you had more of an awakening before me, and now I'm kind of catching up to you as far as getting into some of these.
You'll never catch up, bro.
ideas.
I got years ahead of you now, bro.
Hey,
I tried to bring you in under my wing, dog, and you sank. But now you're
fine.
flying.
I might caw.
But now you're flying, so that's all that matters. No, I'm
But
just
no,
joking.
I might never have I might never have the complete knowledge as you. But as far as the vibration, I think that's what it's. Because I used to say it all the time, like we're only vibrations and this and that, and I did believe
We're
it.
We're gonna get a shirt made with Maurice's face that says Mr. Vibrations on it. This guy in vibrations.
Feel the vibration.
This guy in vibrations lately. So this one is an interesting one. I want to make a point about this one. So this was a headline, or there was, all these different science outlets and media outlets and online outlets. They all have like kind of the same title, but it's varies in a little bit of ways, But it's scientists reverse the arrow of time in quantum computers. So, or in a quantum computer. So that sounds like awesome. That sounds like, oh, we hacked time, or we can go back, or there's a time machine, or simulate it, or whatever. And a lot of news and, again, media outlets, they use these like sensationalized or sexy headlines, and they use titles like "Scientists have reversed time" or "Quantum computer used to reverse the arrow of time," stuff like that. But then there's other places I go after that. So then I go to this, for this one, I went to the MIT Tech Review. So, and again, not all of these are like that, but they're trying to get clicks, obviously. So, the MIT Tech Review, they broke it down as, again, that this is sensationalized and the arrow of time was not really reversed, nor are we any closer to building some sort of time machine. And what MIT... what the article was saying was that a good analogy for what they did figure out would be to like imagine a movie or a clip and then play it in reverse. And then what they really did was some quantum computing version of that, which is cool. And another analogy would be to reverse the dispersal of light, like when you're focusing a lens. So like when you focus a lens, like doing the reverse of that is kind of what this was.
Yeah. Wasn't there some scientist in like Antarctica that I thought I read something about him being able to reverse time? There was some kind of activity where like because he was at a certain location. Do you know what I'm talking about at all?
I mean, can you pull it up?
No, I'll stop talking about it today. Maybe we can pull it up for next time. I'll find more information about it.
Okay. Um, yeah, I mean that sounds interesting.
Yeah. Sometimes there's some juicy little tidbits that squeak through after you read about all the misery. But
Yeah.
that's what we're here for, ladies and gentlemen, to get some good vibes out there.
Every like time we come back, you go at the very end. You're like, well, but we're gonna get to that later. We'll
Yeah.
come back to that, folks. I like it. You're like our segue guy. What else did it say? Okay, this study and research would be used to help test quantum programs in the future. So it's not even really that helpful. I mean, I guess that's kind of cool if you're into quantum program testing, but
Well, I think that because these computers are so fast, they're going to be able to crunch enough information to really understand why the universe works.
right.
So we'll see. I don't know if that answer lies digitally, but we'll find
I
out.
thought you were gonna say the middle. I was gonna say we're gonna make a bunch of Maurice shirts. Oh shit.
Yeah, this thing. I love that you get to rip on me, but
You can rip on me. Go ahead. I
no,
don't
it's
give a
cool.
shit.
I put myself out. That's
You
kind
did.
of the,
Remember, I ripped on myself with the knows.
Oh yeah, I do remember that. But no, before I was a little more apprehensive of putting myself out there. Now that I actually feel like I'm connected to this new thing, I'm just gonna be myself and put it out there. And if
Yeah,
people like it, they like it.
these
You know what I'm saying?
vibrations are connected to the universe, dude. Come on.
Yeah, vibrations. No,
Scientists
can't,
Scientists detect large structures near the Earth's core. So this one was spread around pretty good. I saw it all over online. It kind of ties into the super volcano episode we did, and also the tidal forces episode we did with Chris from Dabbler's Den. And geophysicists at the University of Maryland use sound and seismic waves traveling through the Earth to detect large structures between the molten core and the solid mantle layer. So you can pull this up online for a visual. I was looking for a good picture, but I mean, with all the you got to be careful what you put up on YouTube these days. They take down stuff for no reason. So
yeah.
Okay, so these hot, dense structures were found under, like, by the core by where, like, Hawaii and the Marquesas Islands are. And the study was focused around the Pacific Ocean basin. So they're saying that there's these very hot, dense structures that are in between the core and the mantle by where Hawaii and the Marquesas Islands are. So we're talking about
A lot of magma.
a lot of hot spot action.
Well, that makes sense because Hawaii is just a bunch of volcanic rock piling up.
Right. The data was compiled from 1990 to 2008 and consisted of more than 7,000 seismographs with a magnitude of 6.5 or higher found around the Pacific Ocean basin. They used a machine learning algorithm named Sequencer to analyze the data. So yeah, that's pretty interesting. I mean, that's a lot of seismographs. So now I wonder too if that's something. Is that been looked into around the world, or is this like the first place? Or is, you know what I'm saying? Because this is actually kind of in the Ring of Fire area.
Yeah. I mean, it sounds like they kind of zoned into that area knowing how Hawaii is, and they're figuring, let's go as deep as we can and see what's going on down there.
Right. Yeah. I mean, that seems and like we mentioned before too, when Chris was on during the Tidal Forces episode, and we talked a little bit about the supervolcano. They don't know what the exact mechanism is for these hot spots, like what causes them, you know, where did they come from, that kind of. There's ideas obviously, but yeah, it's interesting stuff. They found echoes on 40% of the seismic wave paths. So when they send the signal out, they wait for it to come back. I think they said they found 40% of them came back. The patch that they found, or the patch of the hotspots here, they said it was very dense and very hot, and it gave off unusually loud echoes. So I don't know. I'm not.
So it's not hollow in there.
No. I mean, if it's loud, well, I would assume the more loud it is, the more solid something is in there, is what I would say.
Yeah, it would come back stronger because it would
Right.
have more of a solid base to ricochet off of. You
Right.
would think.
You're not losing.
Again, I'm no expert here.
Well, I mean, we are kind of sound. I mean, at least I am. I understand sound very well, and I would say that that something solid would send you back a more precise signal. Is something that's more permeable probably eats up part of that signal.
So it's denser than magma, is what you're saying. It's not liquid. It's some
Yeah, I
kind
don't.
of
They don't know. I mean, there's no way to tell. The
right.
deepest they've drilled, I think, was like 300 feet or something stupid. I don't look that up. Somebody commented on our. I think it was the Tidal Forces one. I forget. Maybe it was the super volcano episode, but
7.67 miles.
yeah, that's nothing, and that's Russia, right, or Siberia?
Um,
I forget. There was like a name of it. They had to abandon the operation.
Sakhalin or
I
yeah, that's
think
pretty. That's deep, but it ain't that deep.
no, it's not deep at all. Not deep at all. So see how far, or the to the center of the Earth, how far that is. So it's
Trying to find
we've
that
gone
right now.
7 miles into the Earth. How far is the core, the center of the core?
Distance to the center of the Earth.
Come on, young Kevy.
66370 kilometers. How many? What is that? What are we doing with kilometer? Oh, okay. So it's
6,000.
30. It's 4,000. It's 4,000 miles to
Oh,
the
okay.
center.
That's a lot. So
Get out of here with your kilometers.
yeah,
We actually should switch to kilometers because
you had a tough
everybody
time.
else.
You had a tough time with the standard system.
But no, we should switch to kilometers. What are we doing? We just want to be so different than the rest of the world.
Yeah. Yep. All right.
So yeah, so we've bored in
Yeah.
7 miles, and there's 4,000 miles to the center.
Yeah.
That's intense.
It's nothing.
So yeah, we don't know. I love that. I'm looking at all these drawings right here. It's like, yeah, it's kind of what you thought dinosaurs looked like.
You
Now
literally
this-
have a
now the
bunch of little.
T-Rex-
You have a bunch of little pictures you drew in preschool in front of you right
Yeah.
now of the Earth's
Uh-huh.
core.
It's just funny though how you get. It's just in your mind, like the look of the Earth and all the different areas of it. But how do they really know that? They're just guessing.
Yeah.
It's an educated guess.
It's
to
not.
a
I mean,
degree.
it's
Again,
not
I'm not
guessing.
saying that
I
this
mean,
is wrong.
they have an idea, and I assume that they have different. Like again, they've used seismology and seismic activity. They've probably
Right.
been able to scan some things. But again, yeah, I mean, Chris has his master's in science and or geology. He was on there telling us that they don't know a lot of stuff, so that's why you gotta keep chipping away and keep figuring it out.
That's why I brought up that the look of the dinosaurs, because now they're saying that the T-Rex might have had wings. Those
Yeah.
little arms were more of like a wing, something to hold a wing up, which makes actually way more sense if you think about it.
Yeah. Okay, so some crocodile ancestors may have walked on two legs. So fossilized tracks were found preserved in a South Korean rock formation. So the picture of these things is kind of what you would imagine. It literally looks like an alligator that kind of stood on its back two legs,
Uh-huh.
or a crocodile on its back two legs, and was tilted forward, just hovering, but more lengthwise.
Right.
The tracks were dated to around 106 million years ago. The crocodilomorph tracks were roughly 2 to 3 meters long. And they've said that there's a few other spots that they found these kinds of tracks where they now believe that this is possible, that these ancestors of the crocodiles were walking on two legs or bipedally. The one, what was it? Okay, so yeah, the bipedal crocodilomorph that was responsible for a set of tracks found in 2012, not far from this newer find, they initially thought was a pterosaurus, like one of those flying ones, but they believe that that one walked on four, meaning I think its front two like wing things had arms or
Yeah.
something like that. I think I've seen something like that on Jurassic Park too. I don't even know if it was real, but I assume that they did a little bit of homework for that movie.
Yeah. Yeah. Maybe the first one.
You think? You don't think that the newer ones they
No,
did?
they might. They probably have some scientists on there. They have unlimited amounts of money. I'm sure you could cough a couple mil at some crack team of experts. But wouldn't that be scary to see that thing running after you?
Yeah. I mean, okay, so the newest one they create some like brand new hybrid dinosaur. I'm not talking about that, but I'm
Yeah.
talking about like the general ones that they have in the park where they're like, "Oh, blah blah
Hmm.
blah" or whatever.
Yeah, I'm sure the real names.
But you bring up a good point about like not knowing what they look like precisely. Like you just imagine them to be these like reptilian style creatures, very scaly, something. But now, like you said, and we know that the birds are an ancestor to, or they've evolved from
Yeah.
dinosaurs. So yeah, I mean, who knows exactly what they looked like? They could have been like these massive predators. Almost think of like a massive eagle or a hawk that
Yeah,
that
that thing
has
would
like
be
less
intense.
wings, but like walks around and just crushes.
Yeah, my friend has chickens in her yard, and she was like looking at them the other day, and she was telling me I could definitely see how these are almost like dinosaurs because chickens don't fly or anything. The dinosaur could have been, it could have had scales, but they could have had feathers over the scales.
Yeah, yeah, yeah. I mean, I've heard
We
people.
don't know. This is
I've
millions of years we're talking here, folks.
I've gotten in some interesting arguments with people over the years that some people think that they could have looked very different. Same obviously the bone structure, whatever,
Hmm.
but
Yeah, that's all that is
maybe they look
bones.
like there's some. I've talked to some people that think they're more mammalian looking. I don't agree with that at all, but I could definitely see something like a mix between like a reptile and like a bird of prey or something like that.
Yeah.
Um, roughly 231 million years ago, uh, Carnifex carolinensis, aka the Carolina butcher, may have roamed North Carolina. It was a bipedal ancestor of the crocodile. So
It's a
look up a picture
phenomenal
of
name
this.
for
Yeah,
this thing.
the Carolina butcher was like a bipedal, crazy looking dinosaur. Kind of looks like a crocodile a little bit, but a little bit more a mix between maybe like a crocodile and a T Rex.
Yeah, here it is. This thing's sweet. I would love to show everybody, but we don't want to get flagged here.
No, I mean it depends on if it's some of
ABC News.
some of them can be shown, some can't be. It just depends. Uh,
Well, should we give a little peek to these peeps? What's going on?
no, no,
No?
they
Oh, come on.
no. What I'm gonna do is I'll put all the links to all these articles, or at least since there's different variations of these articles spread across different outlets. I'll put a version of each one of these articles underneath the video when we're done, so people can go look into them more if they want. But really, I'm just sucking the juice out of these things and giving you guys the juicy details.
Yeah. We'll do all the work.
Einstein's theory of relativity holds up again. So the strong equivalence principle states that any two objects in the same gravitational field will fall with the same acceleration regardless of their mass or composition. This was shown by Galileo when he dropped two spheres with different masses off the top of the Leaning Tower of Pisa, and both landed at the same time. So this one, they're just showing that. So what they did was these researchers at the University of Manchester measured the movement of a white dwarf star and a pulsar, and researchers found that they orbit exactly the same, which was kind of a they didn't know what to expect because pulsars are so large that they thought that it would act differently since it was so big. So that was kind of the twist when they used different gravity models. But in reality, it just goes back to Einstein's theory, where again, they kind of were on the same track, you know.
Dude was on point. What can we say?
Yeah. Um, but it's interesting too. So, um, I think when you look at this stuff, there's there's not just people trying to like continue to prove his theories right, but there's also people every day trying to disprove them. I remember I think there was a documentary on Netflix. I don't know if it still is, but it's like it was called something like "We Proved Einstein Wrong" or "Einstein Was Wrong" or something like that. I don't know what it was, but and I don't even remember actually what the whole premise of the documentary was. I don't even remember watching the whole thing, so it might have just been BS. But I do remember thinking that like it's funny how science does that. You know, these people are constantly trying to one up each other or disprove each other. I think some of it's probably just the scientific method. People thinking they know better than somebody else, or using the scientific method to point out the fact that there's holes in other people's stuff or whatever. But at the same time, we all are human. We all have egos. We do have agendas, whether we believe it or not. There's cognitive and confirmation bias and all sorts of biases that we have. So I think that it's just interesting when you look at this that Einstein has been this right for this long, and we haven't seen another Einstein really since. I mean, yeah, there's been people that have made large contributions to the hard sciences and physics and different things, but you know,
Yeah, but it's good to have people that are questioning and pushing because then you'll never go anywhere. So, but Einstein holds up again. Don't mess with Einstein.
yeah, I wonder if he was still alive today, if he would be still cranking.
He'd be upset, my friend.
Because he'd be upset.
He'd
He'd be upset by the
be
vibrations.
scratching his beard.
I don't think he ever had a beard.
Oh no,
I
no
was
beard.
gonna say, now you're putting something onto this man.
Yeah.
Okay, so this one I took from our super volcano episode and slide only because this was an article that I added into that presentation or that episode. But I think it's super relevant to what we've been talking about, so I'm going to go over it again. Excuse me. So a hotspot under Yellowstone has migrated over time from southeast Oregon through Idaho to the northwest corner of Wyoming. And as we were talking with Chris from Dabbler's Den on the Tidal Force episode, it might seem like it's moving towards that way, but what's really happening is the crust is actually moving the opposite way. So while the hotspot is staying still, the crusts are moving over that. So that's the path in which the crust is moving from northwest to southeast, or at least that part of it, or whatever. So Thomas Arnaud, a geochemist at the University of Leicester, and his team used paleomagnetic analysis because the iron that was ejected would have been liquid and would have settled and cooled towards the magnetic north. So this is in reference to two supervolcanic eruptions that happened roughly, I think one of them was 8.9 million years ago, and the other one was like 8.6 million years ago. And let's see here. But yeah, McMullen Creek was a super eruption that was dated to 8.99 million years ago, and it covered over 4,600 square miles and stretches what is now southern Idaho. It registered an 8.6 on the VEI index. If you remember our supervolcano episode, the VEI is the Volcanic Explosivity Index. And 8.99 is literally the highest that the scale goes. So the McMullen Creek super eruption would have been the largest eruption that we know of at this point.
Yes, sir.
The Gray's Landing super eruption, same southern Idaho, was dated to 8.72 million years ago, and it covered 8,900 square miles in southern Idaho and northern Nevada. It registered an 8.8 on the VEI and is rated. I'm sorry. I'll fix this in a second. 8.8 on the VEI and is rated top 5 eruption of all time. The VEI only goes up to 8.9. So I got those confused. The Gray's Landing is actually
the big boy.
The big boy, which is an 8.8, which is 0.1 or 2 off from the top of being the VEI. I was looking at the 8.9 million years and thinking that that was the VEI, but the VEI on McMullen Creek was only 8.6, which is still massive. Still one of the larger ones as well. But yeah, Gray's Landing would have been the largest super eruption, 8.8 on the VEI. And some geologists agree with the findings and suggest that we still don't really know what the cause of magnetic flare-ups, especially over hotspots. The U.S. Geological Survey geologist Michael Pullen said it would make sense that the Yellowstone hotspot would weaken as it migrates inward towards the thicker crust of the continent. Still, other scientists suggest that all this only makes sense if you look at the largest eruptions, even though there are other super colossal eruptions that are just as dangerous. So I'm going to pull up a little picture. So this is that... this is the hotspot path. So you can see 16.1 is where it started, and slowly over time it migrated, or we migrated, however you want to put it, all the way up that pattern through to northwest Wyoming. And you can see there at the bottom of Idaho those big spots there. That's probably where all that was going down. 10-7, 10-7. Any questions?
No.
Yeah, I think
I want to go backpacking there. I was looking at a place. It's called the Last Frontier in the Lower 48. And it's like,
that's the name of the trail?
It's called I can't remember the name of the trail, but like that's like the tagline. Like, yeah, you're gonna see bear. You're gonna see. They say you have to go with at least 4 people, because grizzlies are out. Like, that's the only place in the lower United States where there's still grizzly, I guess. Maybe in Montana too, but yeah, that's the scary stuff, bro. I watched this movie the other day. It was based on a true story, and guy went out hiking with his girlfriend, wanted to take her to his secret spot when he used to go there as a kid, and then he went and they got fully lost, and he was killed by the bear. She actually survived.
Really?
Yeah, he got mauled up by this thing, and she had to hike her way out of it, based on a true story, folks.
Wrong Turn 7, Grizzly
edition. Grizzly Adams.
All right.
But a beautiful state. I would love to go there. I haven't been there yet.
And we'll be doing a part 2 on the super volcano, and probably part 3 at some point. But part 2 will probably be on all the other super volcanoes, because obviously part 1 we focused on Yellowstone caldera, right, caldera, and Lake Toba. So the next one will focus on all the other ones that are the lesser known ones. Why is the universe's expansion speeding up? One of the main anomalies cosmologists experience is how fast the universe is actually expanding versus how fast they predict it to expand using the Hubble constant. The Hubble constant, you ask? Yeah.
I do.
The Hubble constant is the measurements of radiation emitted shortly after the Big Bang. So if you remember, we had Brian Keating on a long time ago, but I think that was part of what their experiments were. We're using the cosmic radio background, or cosmic microwave background, to look for ripples in space-time that are from the Big Bang, to kind of measure, or they're looking for like gravitational waves, I think is what they were doing. But yeah, again, this is one of those things where when they think they've got it, they don't have it, because there's so many different anomalies. And the discrepancy is known as the Hubble tension. So they have all these models where they can figure out certain things using mathematics and different things, but then there's certain things where even when they try and predict something, they can't, and it's an anomaly based on what we know so far. And I think with this is an interesting one, because this involves obviously what's going on. You know, if our universe is constant flux, there might be no way to understand, what they're trying to figure out, which would be how fast is it, or what's the speed of the expansion.
Yeah.
Maybe it doesn't follow a set of rules. I guess that would maybe be an option. Maybe it's not. I don't know. I'm not a.
Well, let's keep dumping billions into this thing, and we'll see what squirts out.
I don't think. I think if they did, they might get some answers. I don't think they're dumping billions into this.
No,
thing.
I know. I'm kidding.
Some astrophysicists think that there is no discrepancy and that it is human error or miscalculation. But if there is, this means that scientists are missing, or there's something missing from the current model of our universe. So it could go two ways. You could say maybe the people doing the research or the calculations had some sort of an issue or something, or maybe they just left something out. But I don't know why.
Yeah, there's something missing. It's called dark matter, man. We have no clue what this stuff is.
But how could you publish something and have people review it if they're just going to look at it and be like, this is miscalculated? You know what I'm saying? I don't know.
Now you're onto something, my friend.
So, and then Avi Loeb, who we've talked about before, when the Oumuamua, the asteroid that came from outside of our solar system.
A weird looking thing.
And he was the one that theorized that, or hypothesized that maybe one of these things, or even speculation, I guess you would consider, that one of these things could be some sort of extraterrestrial satellite or something like that. So Avi Loeb of Harvard and two collaborators hypothesized a form of dark matter that decays into lighter particle and massless particles are called dark photons. The more that dark matter decays over time, its gravitational pull would have lessened, and the expansion of the universe would have sped up, relieving the Hubble tension. So there's a few. The thing was too long, so again, I'll put these articles down below the video afterwards for people if they want to look more into this. But the one article, there's a few different ways where they think that they can fix that tension or the issue but nobody's proven anything yet. So
we'll see what happens.
But we'll come back to that.
Yeah. Well, that's what science is, isn't it?
It's
right until it's wrong.
Trial and error.
Yeah.
Okay, so this article talks about dark matter search detects unexplained signal. The scientists working on the Xenon 1T experiment detected more activity than they were expecting while searching for dark matter. The extra unexplained activity or events could be proof of hypothesized particles called axioms. There are two other possible explanations that require physics to explain. Our universe is made up of roughly 85% dark matter, but we still don't know what it is. I mean, I think we know what 4% of the universe is made up, and then you've got the dark energy as a portion of that, and then the remaining portion is the 85%, which is dark matter.
Mm-hmm.
Dark matter does not emit or reflect detectable light, so that's, and then I think Vera Rubin was the first person to see it or discover it, and I don't know if it's true or not, but there was some people speculating that maybe this stuff is what propels the spiral galaxies. Like you look at a spiral galaxy, it's the dark stuff in between those like arms coming off.
Uh-huh.
Maybe that has something to do with it. I don't know. Maybe I misread that, but I thought that that's what the case was.
So what's going on at CERN when they're colliding all this stuff? Are they coming up with anything, or?
What do you mean?
Because they're trying to figure out what dark matter is, right?
I think they're trying to figure out what a lot of things. I don't think they're specifically. I don't think they're specifically like, let's figure out dark matter. Here's a super collider. I don't think that's the case.
Well, no, they're just trying to figure out the particles, regardless.
Yeah. I mean, they've discovered lots of stuff, but yeah, I mean, there's some people that hate that. I don't know why, but
because they think they're messing with the.
They think they're like busting open portals of space time and. We're in a weird. What's the thing that
the Mandela effect?
Yeah, that's the dumbest thing ever. It's just people.
No, that's not right.
It's flawed memory, is what it is. It's flawed memory.
Right. Yeah. Well, I'd bet on the human making the mistake rather than documentation making the mistake.
Dude,
the humans have been proven over and over.
You couldn't even tell me the last 5 articles we just talked about in this episode. I guarantee it.
True.
And I'm not trying to say it to challenge you. I'm just trying to prove a point about the human mind.
Well, it depends on what like makes its way into like pop culture. If Luke, I am your father, made it into pop culture instead of I am your father or whatever he says, the real thing he says, then that's what people are gonna pick up on more because they're gonna.
Here's what
It's
it
just
is.
like
Some dumbass has to do in like a movie in the 80s is say, Luke, I am your father.
right, yeah, that's
And
what I
then all of
think
a sudden it gets perpetuated. And then people are quoting a movie line from a different movie that's talking about that movie, but you only
Mm-hmm.
focused, like what you're saying, on the pop culture aspect of it.
Yeah, because I remember I did watch that and I go, oh, he doesn't even say that.
Yeah,
That's one in particular that I
people
remember
get crazy
watching.
with that too. It's like, no, stop, just stop.
Well, people like to look for mysteries, and I
No,
get that.
I'm all about mysteries. You know I am, but come on.
It was fun for a week.
Researchers learn more about solar flares. So, plasma astrophysicist from KU Leuven, I think that's in Belgium, has created the first self-consistent simulation of the natural processes that happen during a solar flare. The team used Flemish supercomputers and a new combination of physical models. A solar flare is a massive explosion that happens on the surface of the sun. The energy released is equivalent to 1 trillion atomic bombs. Very large solar flares can affect communications and electronics on Earth. They have an effect on our magnetic
Temperature.
fields. Well, yeah, no, magnetic fields. And I think there's the Carrington event. Look up the Carrington event. Carrington
Of 1859.
Yeah.
It was a geometric storm.
Yeah. So those can happen. I mean, we could get our stuff knocked out by some supermassive flare.
That's funny that you mentioned that. I just watched a movie called Knowing with Nicolas Cage, and it's all about this flare coming. It's weird that you're bringing this stuff up.
How was it though? How was the movie?
It wasn't very good, folks. I'm not recommending this movie. It's interesting to a degree, and the ending's pretty cool, but yeah, it's all about a solar flare, and he's like a professor at MIT, and
so yeah,
Nick Cage is no professor at MIT. I'm gonna have to call you out on that.
So there's the Carrington event. Also, you look at like ancient times. You have other theories too. You have like Dr. Robert Schoch's solar induced dark age, or SIDA, where he talks about also his theory with the younger dry stuff. It wasn't an impact, but it was actually one of these large plasma events or these solar flare events that completely, knocked stuff out of and like did you ever see that interview that he did with Rogan?
It kind of
where
rings a
he's
bell.
talking about like how like literally there would be like lightning raining from the sky, like you'd have to get into cave systems or something to avoid if there was one of these massive solar flare events.
So it wouldn't like just engulf the flame, like engulf the whole planet in the flame like a nuclear bomb. It would just be different.
What do you mean the flame? No, the solar flare happens on the surface. Even if there was a massive one, it wouldn't reach us. It's not the actual flare, I don't think. It's like the energy that comes off of it that disrupts our magnetic field. So they can also be very beautiful. So magnetic or the solar flares, they create basically the northern lights.
Yeah, an aurora.
Yeah, that they affect our magnetic field. And they also convert energy from magnetic fields into heat. So
me being a photographer, am I hoping for a flare? What's going on here?
Well, are you into astrophotography?
Yeah, I love that aurora. If I could see it, I saw it once in Lexington, Michigan, but it wasn't very colorful. It's weird the aurora borealis will like scoop down into because I know if you go up to like Traverse City, you can see it. You can see it up there pretty good.
Yeah.
But Lexington's it's like an hour, 2 hours outside of Detroit, so it's pretty close to a big city. But I did see it. It was a blue shimmer in the sky. It was pretty cool.
Yeah, I've never seen them. I hope one day I can, but have not.
I would love to go to Iceland and do some stuff.
I know there's a lot of people on Instagram from Iceland that run those like astrophotography accounts where it's all just like northern lights and stuff.
Incredible.
Finland, Iceland, all up there. That's where you get all that.
But now you have to even question because everybody's using Photoshop and stuff. It's like, are you just taking a picture of a really nice landscape and then taking the astro picture separately and then melding them two
So you think that
together?
they're like photoshopping the sky onto a better landscape?
Well, a lot of the things that they do, you have to because of the exposure. But again, like if you're sitting there with your camera and you expose and you shoot the mountain and the lake, and then the next shot you expose for the Milky Way, I don't have a problem with that. I have a problem with people shooting like Las Vegas and then all of a sudden they're putting the sky from
Yeah.
Iceland up there. You know what I'm saying? Like
Yeah.
I'm more of a I like to shoot what I see with my eye, but at the same time I've put in like a little bit like I made like clouds a little cleaner and things like that. But yeah, I don't know. I mean, there's a level you have to draw there.
Yeah, that picture you took of the moon was pretty cool the other day.
Yes, yeah, that was lucky because it was just coming up. So a lot of the times when you shoot the moon, if you want to get the detail in the moon, you have to expose just for the moon, and then usually all the landscape is in black. Because if you expose for the
So then
landscape,
how do
then
you
the
make it
moon's
so
like
then you go it's like what? You go after you do it afterwards? You
I have done it. I've done two pictures. Like you sit
what
in the same perfect spot, take two pictures, and then the where the
what
moon
in
is
Lightroom
exposed
or
well.
something?
Yeah.
So yeah, I mean I don't again that's pretty interesting, but I would hope that there's some way to do that though where you don't need to do that. Like maybe people are just taking sick pictures. At least that's what I want to believe, but
Right. Well, I'm sure they are. Don't get me wrong. I'm just saying, like a lot of these, like this one dude's picture, because I follow a lot of the stuff from Detroit, like Belle Isle. It's Belle Isle, like these trees, and then in the background, it's like an insane looking galaxy. Now, that
yeah.
wasn't shot there, my friend.
Yeah, that's awesome.
But again, then you have to take into consideration what's the artistic. Like, I respect artists that take pictures and manipulate them and use the computer as their medium for painting, essentially.
Right.
So I don't know, but I'm also more of a purist because like I like to go backpacking and stuff, and it's not like I'm putting mountains behind me. I'm actually at these places, so I don't know.
Right.
Some people are very purists and they don't like to edit stuff. Some people like to go bonkers, and that can be cool too.
But you are right though, like Instagram, like people if you're going to doctor stuff up, it's usually on there because people want to with even like the Instagram algorithm now, like it's got to be juicy for people to click on this thing.
Yeah, yeah. And if anybody wants to follow me on there, I'm at Maurice_Hogan. But I try and put up like a nice looking picture and then a little
Yeah,
inspirational quote.
he takes nice pictures of the sky. He takes, artistic photos, sick nug photos, you name it.
Can't take the cannabis photos anymore though because they don't want drugs on there.
Yeah. Yep. That sounds about right. Even though it's legal.
Yeah, but it's not.
Yeah.
I don't know. I mean, that's the world we live in. It's legal, but it's not legal.
Right. Yeah, well, I mean, yeah, but give him a follow on Instagram. He does take some cool.
I popped my name up in the chat over in the corner. Not trying to
Ooh.
shamelessly plug myself, but
He's
it's
plugging
going to be all
himself.
connected.
We're
Yep.
gonna go on a little Maurice run here tomorrow night. Tomorrow night we have David Matheson on. We're gonna be talking about star myths from around the world. So
Sweet.
tune in tomorrow night at I think what did we say? So it's like 11 p.m. Eastern time. And yeah, we're going to be talking about star myths and correlating the stars to mythology. And we're also going to be having a Arthur back on for part 2 of the Norse mythology as well.
Which involves some of the stars too, and I actually like that topic a lot because everybody's going up north, and it's a great time to do stargazing. Me and Michael do it every year up in Manton, Michigan.
Yeah. Yeah, we do. It's pretty crisp up there. I mean, who knows what's going to happen this year with everything going on, but
Yeah, it's wild.
it's nice to get up there. You can see literally stars from horizon to horizon, and you have you can see the satellites pretty clearly just moving around.
Yeah, they actually have these parks called blackout parks. They're specifically designed for night landscape photography. There's one up in on Lake Huron, and there's a couple up in Traverse City area. I'm really looking forward to checking one of those out, but that would be where you could see some borealis, maybe the Traverse City one.
Borealis, more like Snorrealis. You're
Are those steamed clams?
um, but yeah, I think that when you look at all these articles, I have one thought on all this, like one general overarching thought, which is that I like reading these articles and I like, retweeting them and different things. But then at the end of the day, a lot of them are just speculation. Even the research that they've analyzed, like that one they did 7,000 seismographs to figure out what those dense hotspots are out in between the core and the mantle, and they have an idea, but they don't know. It's stuff like that. So again, I think that's what makes science interesting, and I think that we need to hear less from the scientists that pretend like they know everything and more from the scientists that are philosophers as well, that understand that while some of these things are important, that it's just another step in a direction.
Yeah, a lot of the doctors and scientists we have on this channel seem to be pretty open-minded. I like to get that kind of information out into the world, that kind of thought pattern.
Uh-huh. So, but that's it. Is there anything else you wanted to get in here before we wrap it up?
No, sir. Good stuff. We should probably start doing these once a month at least, but
Yeah.
I'll try and find that article about the guy in Antarctica that was
if you
messing around
see
with
any
them.
articles too, feel free to send them my way, and that goes for you listeners too. If you find some cool scientific article or something you want us to talk about or bring up on the podcast, shoot me an email. Go to our website, mindescapepodcast.com, and go under contact and send me an email.
For sure. And if you like what we're doing with these, not random, but just some of the scientific research and some of the current event stuff going on in the science community, leave us a little comment. Let us know you like that stuff, and we'll do more of them for sure.
Absolutely. And we're at a point now where, obviously we're going to keep growing. We're at a nice, slow, steady pace here, but anytime if you know somebody that likes podcasts, recommend us. We come from that culture. We're big into, Fish and the Grateful Dead, and that's how those people got huge, was just word of mouth, and people liked what they're doing. So same thing goes for us. If you like what we're doing, just tell people about it. We appreciate it. And subscribe to our channel. Check out mindescapepodcast.com. We have everything on there. And again, if you want to join our Patreon for $2 a month, you'll get exclusive content. And we will be coming out with some merch, some shirts and stuff. So, yeah, we appreciate it, guys. Thanks for listening.
Beautiful.
We love everybody, guys, gals, and everybody. Please listen, and we'll catch you tomorrow night with David Matheson. Peace.
Bye-bye.